Hello, this is Scott. Welcome back to my YouTube channel where I cover a variety of different data science and analytics topics, everything from open discussions to platforms. Today we're going to be talking about an open source platform called R, and hopefully you were with me last time when we had a short session on density and histograms in just a couple of minutes in R in our studio. We generated these density plots in a trellis format, and we're going to extend that today. We're going to go into qqmath and qqplots, and we're going to do some quick Box Cox transforms. And again, the basis of these visual graphics are Sarkar, his book. So let me just flash some quick code that we'll go through, and you can take note of this. You'll have this. You can pause. You can follow along. And then I'm going to go to RStudio, and we'll actually execute just these few lines of code. I don't know, probably about a dozen, maybe 15 lines of code or so. So the first was just generate the plot. We're going to look at that, and then once we look at that, we'll see that we probably want to do a Box Cox transform. We'll talk through that and wrap up. So I'm going to execute the code starting here. I'm using this Chem97 data, which you've seen before. It's part of this MLM Rev Pack. And so I'm going to execute that. I can do a summary. I can look at the vectors and factors of this data frame called Chem97. The ones that we're going to really focus in on is this factor of score and this GCSE score will be the main ones that we focus in on today. So if I just look at the top 1,000 of the scores, you can see there. You can also see down here that in total I have about 31,000 rows here. And then I'm going to execute this qqmath. Just to note, I'm going to do it again on that GCSE score across the or conditioning on the factor of score. This vector here, I'm using this data. This F value, all it does is it generates 100 quantiles. So let's just execute that qqmath, and this is what we get. So we get a trellis plot of QQ plots, essentially, using the qqmath. And what I can see here is I can see that, you know, here's the lowest score here itself, right? So this is, well, let's take one quick step. I'm not going to go deep into it because you can do it, but if I go into this MLM Rev package and then I look at this Chem97, it gives me a little bit of information on this, what this is about. You know, it's chemistry examination in Britain. And again, the score that we were looking at is the point score on this A-level chemistry. And then this is the GCSE score, which is the raw. So this is a nominal and a quantitative score. All right. So getting back to the plots. So when I have this low score, these lower scores 0, 2, 3, 4. I'm in this range, more of the 5 range, and I span really quite a bit from 3 on up to 7. When I get into these higher ranges, something interesting is happening. The density is shrunk, right? So I'm actually going from about 5 to 8. So the spread, the variability is not near as great as I get into these higher scores. Also, if this was normal, the plots would be almost on a straight line. So I'm seeing some curvature. In fact, really what I'm seeing is I'm seeing some left skewness. So because of the convexity, it's really a left skewed distribution. All right. So that one's for this, and then if I go into, well, I'm kind of getting ahead of myself there. So if I go in, I can also do this for gender. So again, this is essentially the same command, but now I'm going to look at gender on this 97, and the groups will be the score. This aspect XY just means create a 45-degree line, or that's where it would fall if it fell perfectly. Again, 100 quantiles, and I'm going to create a little text box to the right, and then I'm going to label my X and Y axes. So if I do that, execute that, I get stacked, right? So the groups for the score, I actually get stacked scores across male here and female here. So I can see the comparison there. I'm also still seeing some curvature convexity. So that, again, is consistent. I've got, you know, left skew distribution here. And then I created this little box over here to the right for the pattern. So this is the scores, right? The blue on the bottom all the way up to the green on top for 10. Okay? So the next thing I'm going to do, I do, since the convexity, this left skewness, what I can do is I'm going to do a Box Cox transformation, but I need to know what the correct lambda is to make that transformation. So Box Cox transformation requires a parameter lambda. And here what I'm going to do is I'm going to make sure that all my scores are greater than 0. So anything that's, I've got a bad data value, I'm going to get rid of that. And then I'm going to do this Box Cox, use this Box Cox function, GCSE score by score, and the interaction score and lambda, and I'm sorry, gender. And then for lambda, I'm going to set a grid from 0 to 4 in tenths. All right, so let me do that real quick. And that generates a plot, the log likelihood plot for the parameters given the data and across these different lambdas. And so essentially I'm going to say that the optimal, the highest log likelihood is going to be when lambda is 2.34, and I'm going to use that right here. So I'm going to execute that, and then I'm going to just replot. All right, so I'm just replotting again, and this time I actually remembered my title for my my key here of score, and so I get the same thing, except now that I don't have the curvature that I had before. So if I look back, again, curved after the transformation, now these things look closer to what they should, which are straight lines on the 45-degree axis. All right, so I'm going to quit there for this time. I want to keep these short. Next time what we're going to look at is we're actually going to look at 2 sample QQ plots and some other things. So hopefully you can join me then. Thanks.